So 9 stays outside. The top function prime is 1 times the denominator minus the top times the denominator prime over the denominator squared. Now 9, and then this is negative 2t squared plus t squared. Negative t squared plus 9. Factor out negative 1, and you have t squared minus 9, which is t plus 3, t minus 3, over t squared plus 9 squared. Right here, I can write, although I'm not asked right now to do that, but I know because we went through a similar problem before. So v of t is 0 when t equals plus or minus 3. Not possible because we're talking about time. So only when t equals 3 seconds. Okay, so now we have the formula for the velocity. I'm going to copy it on the next page. So a v of t equals negative 9 t squared minus 9 over t squared plus 9 squared. And in part B, they are asking us to find the velocity when t equals 1. So 1 minus 9 is negative 8. Negative 8 times negative 9 will be 72. And 1 plus 9 is 10. And 10 squared is 100. And I can simplify by 4. And what do I get? I get 1 and 8. And this is, of course, I think it was feet. Oh, where is it? It was feet or meters per second. Let's take a look. I didn't copy that. I forgot. Feet. Okay, perfect. So this is in feet per second. Okay, back. They wanted the velocity after 1 second. When is the particle at rest? So the particle is at rest. That's part C. When the velocity is 0. And we already know, we just determined it a second ago, when t equals 3 seconds. So t equals 3 seconds. D. Oh, I'm sorry, I forgot to stop sharing. Sorry about that. So I was showing this here. So the velocity is 0 only when t equals 3. Both are correct algebraically, but I can't say that the velocity is 0 when time is negative 3 seconds. So I can only consider positive for time. Okay, the next step. Then find the total distance traveled during the first 6 seconds. Okay. So at this point, I will present the velocity. And I can come back here because, as you know, we also need the acceleration. And I can also put the distance, f of t. So we have 0 and 6. And at 3, we know the velocity is 0. And when I look at the velocity here, this is always positive. So this is also positive, so I don't need any of that. And I know that when this is 0, it's going to be positive. And if you plug in 6 on the other side, then it will be negative. So knowing that, then I need to determine, so the particle goes in this direction the first 3 seconds, and in this direction the next 3 seconds. And we know that this is the graph, so that t equals 0. It goes 3 seconds this way, and then it comes back 3 seconds. So right here, this is t equals 3, and right here, this is t equals 6. So this is the positive direction, and this is the negative direction. So in order to find the total distance, I have the absolute value plus the absolute value. One of them is not necessary, but I'm explaining. So s of 3 minus s of 0 plus s of 6 minus s of 3. But why? S is this. Same thing. So I have to go back to the original function and plug this 3 values in. So here's the original function. When I plug in 0,
What?
Yes?
Professor?
I'm ready.
What does S stand for?
So we always, if you go back to the problem, it says S or f of t. So S is the distance.
Okay.
So a
Distance.
particle
Yeah.
moves, a particle moves according to a law of motion. So they either call it S, distance, but you're right, S is a little bit confusing because it could be construed as being the velocity, speed, right? But it's the distance function.
Okay, just
Yeah.
checking.
Yes, sure. Sorry about that. Okay, so when I plug in 0 in the function, I get 0. When I plug in 3, I have to see what I get, and then when I plug in 6. So I'm going to plug this function in as is in y equals. Let me do it on the computer so everyone can see better. So let's do that. So please plug in the function as 9x over parentheses x squared plus 9.
I can't see the calculator.
Oh, you can because I haven't shared my screen yet. I'm sharing right now, of course. Yes, right this moment. Okay, so in y equals, clear if you have anything else, and this is 9x. Because it's just one term at the top, you don't really need to put parentheses. But if you forget to put parentheses in the denominator, then you're not going to get the same thing. So x squared plus 9. And go to second and table. And there is no need to plug in 0, but if you want to, you can. And then we want 3 and 6. So for 3 is 1.5, and I put in the table. And for 6 is 1.2. Perfect. So then, then I have 1.5 minus 0, which is positive, plus 1.2 minus 1.5. Careful, 1.2 minus 1.5. The distance, no matter which direction the particle is going, will always accumulate. It will always be positive. So I don't need to put the absolute value, but you know what I mean. So 1.5, and this is negative 0.3, but with the absolute value is 0.3, so this is 1.8. And since the distance is measured in feet, then total distance will be measured in feet. Any questions so far? Any questions? Okay, let me share now. Let's see where we are. That's not it. Okay, so when the particle is at rest, we know. When the particle is in a positive direction, I didn't write it, so now I'm going to write it. For some reason, I skipped that. Okay, so this is in the positive direction. So between 0 and 3, 0 and 3, positive direction, and 3 and 6, negative direction. Okay, we needed to determine that anyway. Okay, find the total distance we did. Draw a diagram we already did. Find the acceleration at time t and after 1 second. Perfect. So now this is the velocity. This is what I will differentiate to find the acceleration. Not a nice function. So v of t, I'm just going to copy it here. Negative 9 t squared minus 9 over t squared plus 9 squared. Okay. So now we want the acceleration. A of t or v prime of t or s double prime of t or f double prime of t, whatever you want to call it, it doesn't matter. Negative 9 will stay outside patiently. And then the numerator changes into 2t times the denominator. Stop me at any time if you have questions. Minus the top times the denominator prime. Bring 2 in front times t squared plus 9 to 2 minus 1 times the inner function prime, which is 2t, over this to the fourth. Do not try to simplify anything. You must factor. It should clean up very nicely. So let's stop for a second and see if you have questions so far. Any questions, anyone? Any questions? Do I continue?
Yes.
Okay, so I'm going to factor out the 2t, and I'm going to factor out a t squared plus 9 from here, 1 from here. So negative 9, 2t, t squared plus 9. T squared plus 9 to the 4th power. 2t is out. One of these two is out, and one is still left in. This is out. This is out. So I distribute 2 in here. So negative 2t squared and plus 18. Only now I can get rid of this. And I can multiply then. So negative 18t, this is in parentheses, negative t squared plus 27 over t squared plus 9 to the 3rd power. I will remove the negative. So I have 18t and t squared minus 27 over t squared plus 9 to the 3rd. And this is the acceleration. Now the acceleration at 1 will be 18. This will be negative 26. And this will be 10 to the 3rd, which is 1,000. So I will approximate. It's a negative, just says that it's against the velocity, right? It's just a negative acceleration. But it's not what it really says. It says that it's decreasing the acceleration. What am I doing? So 18 times 26 divided by 1,000. Okay, what did I get? 0.468. And the measurement unit, remember, this is acceleration, is feet per second squared. Okay, let's see what else they wanted here. Find the acceleration at time t and after 1 second. We did. When is the particle speeding up? When it is slowing down. Perfect. And the graphs, it's with the graphing calculator. We can do that if you want. Okay, so I'm here. Now, the acceleration is 0 when t is 0 and when t is plus or minus the square root of 27. So, of course, it's only positive because it's time, but the square root of 27, let's see if it's within...
Can you unshare so we can see that screen?
Of course. Thank you so much. Sorry about that. So I'm setting this equal to 0, the acceleration equal to 0. So one option is that t is 0. This cannot be 0. And when this is 0, which means t equals plus or minus square root of 27. And this is approximately 5.2 seconds. So it's within our given domain. So here's 5.2. So it's 0 here and it's 0 here. So I have to study the sign of this. I'm not going to, I refuse to study the sign of the denominator because it's always positive. So when I plug in 1, negative. When I plug in 10, positive. So finally, I draw the conclusion. So these two forces work against each other, so it is slowing down. Here, they are working in the same direction. We don't care which direction, but they are working in the same direction, so it's speeding up. Here, they're working against each other, so it's slowing down. So between 0 and 3, slowing down, union between 5.2 and 6, and speeding up between 3 and 5.2, because both work in the same direction, the velocity and the acceleration, so they make the particle to speed up. A lot of work. Any questions on this? So the only thing we didn't do is just the graph with the graphing calculator. I'm not asking you to copy those graphs. Just to see what happens, just to look. We didn't copy them last time either. We just looked at them. Any questions? Any questions?